So, yeah, welcome everybody. My name's Andrew Bromley. I'm the chair of the Key Yorkshire area in the north of Yorkshire. So, yeah, it's great to see you all here to another of our interactive online events. If anybody has any suggestions for any events, just let me know. We're pleased to host them. And also any face-to-face events, hopefully we'll get those going again sometime soon. So yeah, if anybody's got any ideas and things, just let us know. But yeah, it gives me a great pleasure to welcome Tim Burleigh. Me and Tim go back quite a long way. We used to work together, went separate ways probably about 12 years ago. We both worked in a different industry to rail, but now we've sort of reconnected, both working in rail, but for different companies. So yeah, I'm really pleased to to welcome Tim to talk about Revolution Light Rail. So over to you, Tim.
Andrew, thanks very much for that welcome, and it's great to be back in touch. It's actually longer than 12 years. It's over 18 since I left Vickers Defence Systems. So time does fly when you're having fun.
Oh, yeah.
Let me just check that the technology works, and I'll try and put this presentation up first of all. Hopefully, you can see a vehicle that says the future is very light rail.
Yep, got that. Yeah.
Well, that's a really good start. So we'll press on. Thank you again, Andrew. It really is a great pleasure to be here, albeit virtually rather than in person. As Andrew said, I'm Tim Burleigh. I'm head of external relations at Eversholt Rail. I'm also a fellow of the institution and a member of the Railway Division Board. Quick heads up and pen picture of Eversholt Rail for those who may not know of us. We are one of the principal owners of railway rolling stock in the UK, with an asset portfolio currently standing at around 3,200 passenger vehicles, as well as over 80 freight locomotives. In the context of the Revolution Very Light Rail programme, we were co-sponsors with the Rail Safety and Standards Board, RSSB, of the demonstrator phase of the Rvlr programme, as well as being a principal consortium member. As you'll see in here, we've made a significant amount of progress despite the best attempts of the pandemic, and we now stand ready to take the next steps towards introducing Rvlr into passenger service. I'm presenting today on behalf of the Rvlr consortium that's led by Transport Design International, or TDI, and I'd like to emphasise that what we've achieved is, as with most successful projects, the result of the wholehearted commitment of the whole team from the very beginning of the project. Before covering some of the key aspects of the vehicle design in more detail, we thought it'd be helpful just to give an overview of the design philosophy behind Revolution and show how this will deliver a reliable, high-quality passenger experience combined with the lowest possible costs of system implementation and operation. Sustainability in its widest sense has been at the heart of the Revolution programme since its inception. To create a compelling proposition that will encourage modal shift from road to rail, any very light rail whole system solution must be both technically and economically sustainable. That need has been highlighted both in the Williams-Shapps plan for rail and in the Department for Transport's Transport Decarbonisation Plan that was published in July last year. As a team, we were delighted to see within the latter a clear government commitment to drive decarbonisation and transport improvements at a local level by making quantifiable carbon reductions a fundamental part of local transport planning and funding. We firmly believe that Revolution has a significant role to play in delivering these goals. The Rvlr programme was born out of a challenge set by RSSB on behalf of the Department for Transport to provide an attractive but low-cost rail vehicle solution, principally but not exclusively targeted at rural applications. We'd like to thank the RSSB team for their wholehearted support and advice throughout the project, especially in encouraging us to question the relevance of some hitherto accepted norms where these would have posed unrealistic constraints on achieving our ambitions. We've also received excellent input from the team at the Office of Rail Regulation, the ORR, and we're most grateful to them for their early involvement that will assist us all greatly as we move towards series production. There are two principal system-level considerations that have influenced our design decisions on Revolution. Lightweighting is absolutely fundamental to minimizing costs of operation and thus maximizing economic sustainability. The lighter the vehicle is, the less energy it requires to propel it from whatever energy source, and the less wear it causes to the track. In addition, when line reconstruction and/or extension is being contemplated, a very light rail solution will be able to operate on lightweight modular slab track, which can be laid more rapidly, less intrusively, and at significantly lower cost than traditional heavy rail infrastructure. All those good things said, low overall vehicle mass mustn't be achieved at the expense of robustness and reliability. We'll only persuade motorists to get out of their cars and use public transport if the rail service that's offered is reliable and dependable. Many of the routes on which Rvlr is likely to operate will not have received much or sometimes any attention, perhaps for several years or even decades. And the vehicle design must accommodate this. The laudable quest for vehicle lightness must also be traded against its affordability and supportability. Our approach, therefore, has been to achieve a pragmatic balance between innovation and the use of appropriate proven railway systems. By adopting this approach, we've succeeded in our aim of delivering a significant mass reduction. In its demonstrator configuration, Revolution has an unladen mass of just 24.8 tonnes, compared with around 41 tonnes for a single-car, self-powered heavy rail vehicle of similar passenger capacity. That's a rather roundabout way of saying something like a Class 153. And it represents a saving of nearly 40%. Modularity, both at major system and at subsystem level, is another key feature of the Revolution design. This delivers benefits throughout the product life cycle. In the design and build phases, it simplifies the assembly and integration process, and it facilitates the cost-effective development of variants to meet specific customer needs. In service operations, it ensures that the vehicles can readily be maintained and supported without the need for costly bespoke facilities, special tools, or test equipment. And over the vehicle life, it also assists the introduction of enhanced systems as part of the pre-planned technology insertion programs that are essential to maintain the vehicle's market attractiveness. And that's something that's clearly of particular interest to us at Eversholt Rail as vehicle owners and through-life asset managers. Having hopefully now given you a bit of context, I'll cover in a little more detail some key features of the Rvlr design. The most visible, but by no means the only innovative feature of Rvlr is its body shell. While it has a welded steel chassis, the remainder of the structure uses lightweight materials. The side panels are made of pre-wired composite, and there's 5 of them each side. They're secured primarily by adhesive bonding, complemented by high-strength structural rivets that also assist in locating the panels during build. The cabs and roof are constructed from an aluminium backplate and reinforced composite overlay. The inner surfaces of the side panels are pre-finished, and they form the interior of the passenger compartment with no additional panels required. This again all helps to achieve our goals of keeping the vehicle as light as possible, as well as making it very straightforward to assemble. Each of the composite body panels is interchangeable, and the panels are also individually replaceable in service should the need arise. The modular structure also facilitates the rapid and cost-effective development of variants tailored to specific roles. For example, as you see in the lower left of the slide, a freight version with dedicated loading and offloading doors. Whole life sustainability of the structure is maximized through the use of biodegradable resins. And from a wider sustainability perspective, it's worth noting that at least 70% of the vehicle components for the demonstrator have been sourced from the UK supply chain, thereby reducing the net carbon impact. Worth adding that 70% applies both in terms of numbers and in terms of monetary value. And we anticipate this proportion will increase slightly further as the programme moves into the production phase. Moving on now to the propulsion system. The Rvlr demonstrator specification had been finalised before the then Rail Minister, Joe Johnson. I think he has a brother who does something in politics, or was it parties? But back in February 2018, he declared the government's aspiration to eliminate all diesel-only operations on the UK network by 2040. Since then, as most of you will be aware, the focus on rail decarbonisation has increased even further. The role that very light rail solutions can play in delivering this has been explicitly recognised and highlighted by Network Rail in their excellent and very comprehensive Traction Decarbonisation Network Strategy, or TDNS for short. Thankfully, the Rvlr design team were well ahead of the game. They'd already specified hybrid power packs. The demonstrator has 2 such power packs, each comprising a 2.8 litre turbocharged Cummins common rail diesel engine that in its road applications is compliant with Euro 6 emissions standards, generators and associated cooling group. To our knowledge, this is the first time that a Euro 6 engine has been used in a rail application anywhere. The generator provides power to the bogie-mounted drive motors, and it also charges the lithium titanate battery packs. The power pack control system ensures that the engines operate at maximum efficiency, minimizing both emissions and fuel consumption. The control system also provides regenerative braking that assists in recharging the batteries. This power pack configuration allows Rvlr to achieve zero emissions operation and very low noise running in stations and built up areas and at speeds up to 20 miles an hour. In demonstrator configuration, the vehicle is capable of speeds of up to 65 miles an hour, and we'll be testing that later in the year. It's straightforward to adapt the power pack and battery mix to suit specific operations. And we anticipate that battery-only variants combined with recharging points may well prove the optimal solution for applications where the required operating range and/or line speed is relatively low. Maintenance on the power pack and battery pack can be carried out on board the vehicle or at line side. As you'll see from the lower photo, removal from major maintenance interventions is straightforward. It can be achieved in less than 20 minutes and complete exchange in less than an hour, and requires only manually operated forklifts, as you can see from the photo. Turning now to suspension, we took the decision from the outset to provide Rvlr with bogie suspension to ensure that it has a good quality ride combined with vehicle stability. The bogies themselves are a derivative of an existing Wabtec product developed initially for freight applications. Their robustness in the UK rail environment is therefore proven, and that was a key consideration for us. To this proven design, we've applied targeted mass reduction measures, such as the use of hollow axle Lucchini Unipart rail wheel sets. That gives a saving of over 130 kilos per axle, or just over half a ton per vehicle, compared with the solid axles. We use smaller diameter wheels, 720 rather than 850 millimeters, saving just under a ton per vehicle. Among the lower order weight savings, the use of carbon fiber prop shafts is modest in saving around 20 kilos per vehicle, but their inclusion is fairly typical of the approach that the design team took, really to challenge everything, in that when operating on not very good track, the ability for track disturbances to be fed back through the drivetrain and potentially damage the motors was a key factor for us. And rather than embody heavy and costly shock absorbers, the torsional characteristics inherent in the carbon fiber prop shafts provide that without the extra functionality and mass that separate systems would entail. Moving now to the passenger environment, creating a high quality passenger experience that will attract modal shift from road transport has been a key design driver for the Rvlr team. You should expect it's been designed as a fully accessible vehicle that's compliant with the PRMTSI requirements and includes a wheelchair space. Again, that's been validated by wheelchair and mobility scooter users already. The internal construction with the floor and body side mounting rails makes it straightforward to tailor the interior layout to specific operator and stakeholder needs. For example, it's straightforward to achieve a different mix of bay to airline seating, or to incorporate luggage stacks and bicycle storage. The interior includes all the features that are normal, not only in modern heavy rail vehicles, but also in buses and coaches. And those features are things like full air conditioning, LED lighting, and of course connectivity with an Ethernet backbone to facilitate Wi-Fi capability, and USB charging sockets for personal mobile devices at each row of seats to ensure that passengers don't have phone charge anxieties, to which we're all prone these days. Moving now to the driver environment, the demonstrator vehicle is bi-directional, has two driving cabs. We anticipate this will be the preferred configuration for the majority of operators because it avoids the need to provide infrastructure such as turning loops that can add significantly to overall system costs and implementation timescales. Particular focus has been given to providing the driver with the excellent field of view that's essential for safe line of sight operation. The layout of the driver's controls and displays is drawn on the team's wide experience as well as on operator feedback, and it uses switches for frequently operated functions, and a central high-definition configurable touchscreen display with a series of structured menu options for those functions that are needed less regularly. Drivers are also provided with a suite of onboard cameras and associated displays. Turn now to what we've done and what we're going to do in future to continue the validation of the design. Bringing the demonstrator to our test site at Ironbridge was the culmination of an extensive program of analysis, modelling and testing that began at the outset of the design phase. Time clearly doesn't permit to describe in detail everything that's been undertaken. Just like to highlight a few of the key activities. In particular, the modal, fatigue and linear static finite element analysis of Rvlr's novel vehicle structure to demonstrate that it meets and in fact exceeds the relevant light rail vehicle crashworthiness requirements that we and RSSB set ourselves at the outset of the project. Talked about ride comfort and quality of passenger experience. So as you'd expect, we undertook a lot of vehicle ride and stability analyses under different load and external conditions. And in terms of system integration and reducing the level of risk when we got to full vehicle testing, we did an extensive amount of control system simulation and modelling, including hardware in the loop remote testing, in which personnel in the UK, in mainland Europe and in Scandinavia were all involved working in a virtual environment. That's something that Andrew and I are fairly used to from years gone by in our time in the defence industry. But even now, it's still by no means that common within the rail sector. So it was an area really where the team was pushing the boundaries a bit. Key element of the subsystem validation naturally was the extensive testing and optimization of the power packs and batteries that was undertaken at WMG's very well equipped labs in Warwick. The range of activities conducted there included assessing the battery pack performance at a range of temperatures, as well as evaluating the charge and discharge rates, and again, ahead of putting it together on the vehicle, testing all the power pack operating modes so that we didn't get any nasty surprises. Thankfully, all this prior work at system and subsystem level paid off, and it allowed us to embark with confidence into the full vehicle testing phase. The full vehicle validation testing started in August 2021 at the Quinton Rail Technical Centre, as it was. I forget what Porterbrook call it now, at Longmarston in Warwickshire, after the team had completed their initial functional and safety checks. And the programme is continuing at our site at Ironbridge. Dynamic tests completed to date have included acceleration and braking at variable speeds under different conditions and in primary, degraded and emergency modes. Our focus now for the vehicle is what I call the boring but essential bit, which is extended running against a representative duty cycle to confirm Revolution's overall system reliability and operational resilience. In addition to the dynamic testing, we've also tested things like emergency stop procedures, system power up and shutdowns, and validated a number of other spec requirements statically, such as gauge compliance, heating, ventilation and air conditioning airflows and temperature controls, and all the modes of interior lighting operation, including emergency operation. Final aspect of the programme I'd like to bring out is the invaluable practical experience the whole team has gained from setting up the Rvlr demonstration facility at Ironbridge. We've always been keen to show Rvlr in a representative line reopening context, rather than on a sort of fairly anodyne test track that doesn't represent a typical railway environment. Ironbridge meets that requirement extremely well. Our colleagues at Rvlr Developments, from whom we lease this section of the site, have been hugely supportive throughout since our first discussions and our initial site visit there back in July 2020. We've made excellent progress as a result of this. What we've produced there to support the stakeholder demonstration activities over the coming years, without the need for without the benefit of existing platforms and station buildings, provides an excellent illustration to scheme sponsors and champions of how rapidly a reopening can be implemented, provided that all parties are committed and are aligned in their objectives. Just a few examples shown on the slide. Track inspection work at Ironbridge started in February 2021, with all the necessary remedial work, which involved some sleeper replacement, lots of track clips needed replacing, and a little bit of realignment on certain parts of the route, together with the introduction of additional equipment such as the derailleur to ensure that personnel operating in the maintenance shed had the necessary safety protection. That was all completed in August 2021. The two new buildings, the marketing suite in which we host our presentations, and the secure maintenance and storage facility shown in the slide, were ordered in March 2021, and build work and fit out was completed in June 2021. In parallel with all this, the teams developed and implemented the safety management system and associated operating protocols necessary for this phase of the programme. We made a point of engaging with the relevant safety and standards bodies throughout, both to ensure their buy-in now, where their input is largely advisory, but more particularly to provide them with early visibility of our plans for transitioning to the production phase, when their approval is absolutely mandatory and key to authorising vehicles for passenger carrying service. Since September last year, we've hosted 6 full weeks of visits, plus specific one-off events and media briefings. And that's meant that over 230 people, including representatives of national, regional and local government organisations, train operators and various special interest groups, all of their feedback, which we're thrilled to say has been overwhelmingly positive, has been noted and is being actioned, and it will inform the next phase of work, which I'll talk about in a few moments. Please forgive me if this all sounds blindingly obvious, but I'd just like to remind you all briefly of the wider benefits that railway line reopenings will bring. And I'll use Ironbridge as a specific and very relevant example. The need for cost-effective and sustainable rail transport solutions to encourage the much-needed modal shift from road, to provide local employment and skills benefits, and to stimulate regional economies, has been fully recognised by our friends at Rvlr Development in their Ironbridge Power Station regeneration plan. Reconnecting Ironbridge to the wider rail network has the potential to remove a significant amount of road traffic from the lovely local tourist areas, improving air quality, reducing traffic congestion, and also reducing overall noise pollution. So that's where we've got to. Now on to the key question of what happens next for the programme, or phase 3 as we refer to it within the team. I'll be focusing very much on the plans for the product itself, how it's positioned in the marketplace, and also give a brief recap on the significant benefits that Rvlr will deliver. Our plan and objective for the phase 3 work, subject to positive market interest, which we're happy to say is coming, is to have Rvlr production vehicles built and approved for passenger carrying operations in 2024. This will be achieved by commencing a pre-series mobilisation and production programme later this year. A key element of this is the procurement and assembly of up to 3 further vehicles, which will undergo all the required approvals and certification activities necessary for service operation on the UK network. To achieve this initial pre-series programme, new assembly facilities exclusive to Revolution will be created in the Midlands by Q3 this year. As I outlined earlier, a key aim for us has been to ensure the capital cost of Revolution will not only be significantly lower than traditionally self-powered heavy rail vehicles, but also within striking distance of the modern road transportation alternatives with which rail will inevitably compete. This commercial positioning of Revolution means that for certain branch line reopenings that were based on the assumption of using heavy rail vehicles, the business case for their incorporation that currently exists can be improved. This should make more rural commuter routes commercially viable and thereby enhance wider connectivity across the UK. The reopenings being proposed as part of the Department for Transport's Restoring Your Railway initiative and elsewhere form just one part of the range of deployment environments to which we feel Revolution is well suited. In addition to these, there's the ability to integrate its seasonal or event routes due to the rapid mobilisation that Rvlr makes possible. This is also a key consideration for private sector developers of new residential and business park sites. We've also already seen interest from the leisure industry in North America and in the Middle East, along with commuter applications from Eastern Europe. Through the application of our design philosophy and the sourcing approach outlined earlier, the benefits Revolution build will bring to a number of areas in the UK are extremely high. Revolution's design is both sustainable and fully aligned with the UK Railways' need to decarbonise its operations. One further key benefit of Revolution is the ability to deploy a full system solution in circa 2 years, which is extremely fast against more traditional solutions and will assist in bringing forward the modal shift from road transport that's absolutely essential to meet our net zero legal obligations by 2050. As outlined earlier, we've already achieved a predominantly UK-based supply chain that will bring multiple benefits to the UK manufacturing sectors, to the environment and to local economies. I hope this canter through the phase 3 plan has explained how we intend to build on the groundbreaking work completed to date, and that it's also reinforced the all-round benefits that Revolution production will deliver. I'd like to thank you very much for your attention, and I'll be happy to answer any questions you may have, as long as they're not too difficult. But thank you again. It's a real treat to be here. So please do ask me some questions.
Yeah, thanks very much, Tim. That was really good. A really good overview of Revolution Very Light Rail. We've got quite a lot on the chat, so I'll open it. Yeah, we'll open it straight away to the guests that are on the call. So if you want to raise your hand, and I'll come to you sort of in turn. If anybody's got any questions.
Oh, I can see one in the chat. Have we done winter simulation testing? Because the vehicle build was only completed in summer last year, we haven't done a lot yet, although it's fair to say that we did have to deal with low temperatures on site at Ironbridge through October, November and early December. But more specifically on the power pack, which was critical, before we got to vehicle testing, WMG had the power packs and the battery packs in their climatic chambers, so we did both low and high temperature testing there. Any more?
So I think we've got a couple of hands up.
Oh.
Who was? Let me just see who was first. John Whiting.
Yeah. Hello. Can you hear me?
Yes. Yeah.
I've got two questions in one. So you didn't mention any specific energy consumption comparisons to more traditional drivetrains. So could you elaborate on that? And second, and a sort of related question, is there any possibility of third rail pickup? So you use the battery pack as a bridge between areas?
Yeah, I think answer the second one first. We are already looking at potential third rail operation, but in the context of a sort of rail-mounted fast charging system. We've also got, the ability to integrate the sort of bus-style pantograph charging system. We're not at this stage looking at permanent sort of electric operation, because the routes for which this is destined, or most likely market, are unlikely to be electrified at present, let alone and given the huge workload recommended by TDNS over the next 28 years or so, they'd be low on the agenda. In terms of specific energy consumption, I've got some comparisons. I haven't got them to hand, but if you give Andrew your email address and whatever, I'll get something to you, because we did some comparisons. They were particularly focused around emissions rather, but they have got relative fuel consumptions, and we were looking at Revolution versus something like a 153. I mean, the key thing is you've a lighter vehicle. The other point to make is that the engines aren't used all the time. Up to 20 miles an hour, you're operating on batteries. So there's a number of areas in which we have advantages, but I'll get you the numbers.
Yeah. Okay. Thank you.
I've got a question. David Crosby.
Yeah. Hello. Good evening. Thank you for the presentation. I work at the Institute of Railway Research at the University of Huddersfield, and we were involved in a project developing a prototype carbon fibre bogie, which we tested here. We were able to reduce the weight of the bogie frame by 50%, and that was without any real design optimization. Did you consider the use of a carbon fibre bogie frame, and do you think that the weight savings would be significant in this application?
We did consider it in terms of maturity. Revolution and your work on the carbon fibre bogie were running in parallel. And I think the team, before Eversholt Rail joined it, had made the decision to go for a conventional bogie based on the Wabtec TF25, but with a number of lightning measures as outlined. It doesn't preclude us examining other features and other options in future. I mean, one of the beauties of Revolution is that it's so easy to build that changes can be implemented quite straightforwardly. The challenge will be one probably less technical and more about affordability and supportability in the environments in which Revolution operates. But nothing's ruled out. We will keep looking at measures that can further enhance it.
Okay, yeah, thank you very much.
There's a couple of questions in chat, one of which is from a former colleague who will get very upset if I don't answer them. Philippa, good question. We have considered it. There are the build program, because of COVID disruption, we didn't get to do any advanced testing on wheel slip. We've not experienced any problems to date at Ironbridge, and we have had some frosty days, but there is a parallel program of work to put some of the components on the Whisper rig, and I can't remember where that rig goes or where it's based. But we are planning to do some testing. We have experienced no issues thus far.
Thanks, Tim. That's interesting.
Question from Richard around coupler. Very good point. Yes, it does. We haven't fitted a coupler since there's only one vehicle and therefore nothing to couple it to. But the design already incorporates the interface. It's an oleo telescopic coupler, and the interface has already existed at each end of the vehicle. We've had. It's fair to say we had quite a lot of discussion with various stakeholders who visited around the merits of we probably wouldn't go beyond 2 vehicles, because otherwise you start straying into the DMU, EMU territory, and for all the benefits that Revolution has, we're mindful that there'll be certain bits of the railway where it isn't practical to make it go, because in designing it to be lightweight, we have traded off some attributes in terms of overall crashworthiness compared with a heavy rail vehicle. But we certainly envisage that you'd have to, in areas of high demand, having a couple of units joined together, and that could be good. I mean, people have asked us, could we do, get rid of the centre cabs and have a 2-car unit? And yes, we could. The question is, what does the operator want to do? The beauty of having 2 single vehicles is that in times of low demand, you only need to run one, and then you can bolster it. But I mean, we're all learning. We'll respond to whatever is required. I can see another question in the chat, but there are any more hands up, Andrew, that I've not yet answered?
There's no
right.
hands.
So Jack, you put 2 questions in around battery range capability. Again, good question. The team, we started with the hybrid power packs, and we think that's a good overall solution, particularly for the longer range, higher speed requirements. As I say, the vehicle's capable of speeds up to 65 miles an hour. Running batteries for a long distance at those sorts of speeds would fairly soon deplete them. I know we've seen, and I've travelled on Adrian Shooter's Rvlr Rail product, which gets up to 60 miles an hour quite quickly. But you need to trade off that capability against the range. What we would do for each Revolution build, and what we've been doing already, is look at what's the duty cycle and fit the number of batteries and or power packs necessary to operate safely and reliably on that duty cycle. We wouldn't fit more than we need, and therefore we would tailor the onboard power and energy capacity to suit the operational need. So I don't think there's a single answer there. Stress modeling, slightly different issue in that the cracking issues on the heavy rail vehicles were vehicles that were constructed principally from aluminium alloy. Revolution isn't constructed that way, but because it uses a novel combination of adhesive bonding, mechanical bonding, and various different components. As you saw from one of the slides, we've done a lot of modelling around those conditions. Gareth, you raised a question on crashworthiness. We set ourselves a baseline requirement to be sort of equivalent to or better than a light rail vehicle. We actually ended up in most respects closer to a heavy rail vehicle than a light rail vehicle. I've not got, if there were a straightforward plot that covers every single attribute of the crashworthiness requirements, I'd probably have included it in the presentation. But in most respects, we exceeded everything that we'd aimed for, and we were closer to a heavy rail product than a light one, which I think RSSB and ORR have been very pleased with that, and we feel it gives us the potential to explore certain facets of mixed traffic operation. We're clearly not going to put the thing on a high-speed main line where there's lots and lots of 125, 140 mile an hour and heavy freight traffic. But there's a fair number of routes across the UK where you get 2 or 3 freight paths a day and half a dozen passenger train paths a day, where you could readily interleave a very light rail service without detriment to overall safety. And it's that sort of thing we're looking at. But frankly, we're going for the easy targets first, which is operation on segregated branch lines and so on, where we run into a bay platform and the interaction is with other rail traffic is next to zero. Paul plans to look at wheel motors to improve traction braking, steering and track wear. Don't quite, I mean, we're already using automotive drive motors, and the control systems are based on that. I don't know that we are we are looking further beyond that because it's performing very well at present. Autonomy is certainly something that can be explored further, and the vehicle architecture is well capable of integrating sort of autonomous control as and when that comes to maturity. And there's quite a lot of work going on in the sector anyway. Yeah, we're mindful of the cost impact of crewed versus uncrewed vehicles, but I don't know. Personal view is that I think there'll be some time before driverless operation becomes a thing on something like Revolution.
Okay.
Bruce, you've got your hand up.
Yeah, thank you. Following on from that a bit, what provision have you made on the vehicle for incorporating current digital signalling components that need to go on board the vehicle?
They may need to go on board the vehicles, but is my immediate answer to that, because if it's on a segregated branch, line of sight signalling can be perfectly adequate. However, there is provision both within the sort of power systems architecture and real estate to put things like TPWS, AWS, even ETCS on board should the application require it. But I mean, we are being quite rigorous, and again, RSSB and ORR have supported us in this, in that if we are going to break the mold in terms of affordability and be closer to a bus than to a heavy rail product, if anyone were building a self-powered single car heavy rail product, that is, you know, we need to challenge whether some of these major cost drivers are essential for particular theatres of operation.
Yeah, that's fine. I understand that. But thinking of the unfortunate tram incident, I'm sure there'll be a requirement for something or other, speed control. And just from a practical point of view, I know how difficult it is trying to find room underneath a vehicle for an antenna reader or some kind of generator or something like that. It just can be a practical problem.
No, they're very good points and very, very valid ones. We've allowed space claims for them, but we've not fitted them as standard. They can be integrated, and clearly, should the application require it, they will be. It's just fair to say that as I'm sure you'll know, they are big lumps of cost on when we're trying to keep the vehicle cost down. And railway system affordability is very much under the Treasury microscope at present.
That's great. Thank you very much.
Pleasure.
Anyone else with any questions for Tim? No. So I think that just leaves me to say thank you very much again to Tim. Been a very interesting evening. I've learned quite a bit there, and thank you everyone else for joining and those that have asked questions. I think you managed to answer everything, didn't you, Tim?
I owe the first questioner. Let me just check. It was
John.
Energy consumption.
John Whiting on the energy consumption.
Yeah. What I'll do, Andrew, is email you the document. I just need a bit of time to find it. I know whereabouts it is in the system, but I didn't want to duck out of a good conversation to find it right now. Well, I'll get that to you during the course of the day tomorrow, and then feel free to share it.
Yeah, thank you. Yeah, so yeah, thanks everyone for the questions, and thanks Tim for your time and for answering the questions as you did. Yeah, so if everyone can sort of join me in thanking Tim. So I'm sure everyone was clapping away and things, but everyone's on mute.
Thank you all very much. It's great to have had such a an engaged audience, and they're great questions. Really good points. So thank you all very much indeed. It's been a real pleasure.
Yeah. And hopefully you can come back in a year's time or whatever, give us an update on how you're doing on phase 3.
Well, yeah, by then we'll be underway with it. So, yeah. But any opportunity you get, Andrew and colleagues, to nudge scheme sponsors, please do. And I will. I should have said it at the very beginning. Thank your Network Rail colleagues, particularly Mike Smith, who runs the Restoring Your Railway team, and Simon Coulthard, who runs the Light Rail team. They are giving us fantastic engagement and support. I can't speak highly enough of the working relationship we've established. It's absolutely superb.
Okay. Yeah, that's good to know. Yeah. And we'll do. Okay. All right. Thanks again, Tim, and thanks everybody. Enjoy your evenings, and we'll see you again soon, hopefully.
Take care now.
See you later.
Bye.